Okay, entire radicals and mixed radicals. This is kind of like fractions. An entire fraction, well, let's make it improper. That's all fraction. If I make that a mixed, how many times does that 2 go in that 9? 4. And I have how many left over? Okay, so that's an entire fraction. I'm going to convert it to a mixed fraction. And hopefully we can go back and forth forever. Okay, wouldn't that be fun? Perpetual conversions. Okay, it's similar to this, and this is part 1. It's tricky, so we're going to give it to you in 2 days. Okay, and remember, we're not just talking about square roots. That's a radical, but also cubed roots, maybe 4th roots, okay, maybe 5th roots, so on and so on. Recall, a little bit of review. The product or quotient, what does that word quotient mean? You have a really good memory. It's the answer to a division question, right? The product is the answer to a multiplication question. The product or quotient of the roots of 2 numbers is equal to the root of the product or quotient of the 2 numbers. In English, that's not really that helpful. This is what's helpful in math, okay? Unless you're an English person or you love biology, you love memorizing things, but that doesn't make a whole lot of sense to me, the wordage. This does. If we have root 3 times root 4, I can combine those 2 radicals into 1 radical. They're both square root, so I can combine that into 1 square root of, what's 4 times 3? 12. Okay, that's what this says. Also for dividing. And as we saw before, if you have, I don't know, something like that, okay, it will maybe help us out. I can split this thing up. Here it is down here visually. I have 1 root sign. I can make that 2 separate roots. That's the same thing as the square root of 4 over the square root of 16. Split it up is the term I use, because it kind of, in layman's terms, almost makes sense. Okay, a lot more than what this says. All right, and I know the square root of 4, that's 2. I know the square root of 16, that's 4. And we always want to reduce. This is going to be 1/2. Okay, that's what this stuff says. We saw it yesterday. Here it is again. If you didn't highlight it yesterday, highlight it now. Okay, until it sinks in your head and you know what to do when you see these questions, you're going to refer back to this page a few times. Okay, so if they're separate, we can combine them into 1 radical. If they're combined, if it helps us, we can split it up. And yes, it's going to help us. That's what we're doing today, working with this. Write the following as a product or quotient of radicals. Here we have a single entire radical. We want to split it up into a product. That means product of radicals. And they're helping us with the first question because we have a couple of options for 24, right? There's lots of factors that go in 24. Do we want 12 times 2? Well, they're saying we want 4 times 6. And I'll tell you why in about 10 minutes, why we want those. Okay? This is still an entire radical. Have I changed this? Or is this the same as this? It's the same. Yeah, we don't want to change the number. You can't just make it something else. All we're doing is converting it. Okay? We're converting it from an entire into 2. So I can split this up right down there. That's the square root of 4 times the square root of 6. Okay? That's where we're going to stop that one for now. Root 18. I want to split this up. 18 is 9 times 2. Why didn't we choose 6 times 3? You'll find out in a few minutes. I can split that up into root 9 times root 2. I don't have to put that dot there. Okay, that says the same thing. That's root 9 times root 2. There's nothing there. It doesn't mean it's plus, doesn't mean it's minus, it's times. Okay? This is an entire radical. I want to write that not as a product, but a quotient of radicals. I can split it up. That's root 11 over root 4. Okay? So that's all, hopefully, what you guys finished yesterday. Entire and mixed. Do you think this is an entire radical? Yes, we'll get to that in a sec. All we're going to do right now, though, is use a calculator. What is that? What is root 80? It's not a perfect square, so that means it's not going to be a rational number. It's going to be an irrational number, right? The square root of any non-perfect square is always irrational. But what is it? Root 80 should be pretty close to like 9, maybe a little bit less. Let's go to the hundredths. 8.94. All right, everybody okay with that? 2 root 20. If you have a good calculator, that's all you have to do. If you have a bad one, you got to go 20 square root equals times 2. Okay? But we should all get, hey, the same decimal. 8.94. Come on, pen. All right, 4 root 5. Let's go way out on a limb. What do you think this is going to be as a decimal? Well, that's weird. Because aren't those things all different? Or are they? What do we notice about these answers? Yeah, they're like pretty close to the same. They're actually exactly the same. But remember, this number keeps going on forever and ever and ever. It's irrational because I'm taking the square root of something that's not a perfect square. This must be the same as that. Must be the same as root 80. That's the same number. They didn't change it, but they did convert it from an entire radical to a mixed radical, and then another mixed radical, but a simpler mixed radical. A radical in mixed form. Okay? Complete the following to explain why the 3 radicals are equivalent. Well, 80. Is that 4 times 20? Yeah, sure. And can I split this up into root 4 times root 20? Yeah. And why do we want to do that? Do I have the square root of a perfect square? Like, do we know what square root of 4 is? Yeah. It's 2. So this is 2 times root 20. This is the same as that. Okay? This is the same as that. Is 80 also 16 times 5? It is. That's 10 times 5, 50, plus 6 times 5, if you're good with numeracy. Okay, 50 and 30 is 80. If you don't believe me, put on the calculator. That is 80. And I can split this up into root 16 times root 5. Are one of those a perfect square? Do I know the square root of 16? That's 4 root 5. Okay? I didn't change it. All I did was convert it from root 80 into 4 root 5. And this is the same as that. Okay? We already know that because we made decimals out of them. Okay, now, root 80 is an example of an entire radical. Okay? The whole number is under the root symbol. The other way to think about it is the only number in front of this radical, because there is a number there, you could argue, it's a 1. The moment we put a different number in front of it, like a 4, now it's a mixed radical, okay? 2, it's a mixed radical. The number is not 1. That's the difference. Okay? Just like fractions, there's no number in front here. That's an entire fraction. If you have a number in front, now it's a mixed fraction. Okay? So these are examples of mixed radicals. Okay, and here it is again. This is looking pretty mathy. We got n's and b's and all these other strange variables. I hear all the time from parents, I was really, really good in math until they started throwing letters in there. Okay? I was good when it was just numbers. Radicals expressed in this form are called entire radicals because there's no number in front of it. That's the easiest way to remember this, okay? If there's a number in front of it, I don't care what A is, that's a mixed. And it should be an easy mark, guys. Okay, this is just like memorizing. I'll ask you easy questions. Is this an entire radical or is it a mixed radical? That should be an easy 5% on your test. Examples, is there any number in front of these other than 1? No, okay? Once you do have a number there, it's a mixed. That's all I'm going to say about that. Hey, here's a nice table. What kind of a table does that look like? That's a table of perfect squares, right? All right, now we're going to convert. I already showed you how we did a couple of these. Here's what you need to think. You have to find a perfect square. Think. Think. In that number, the radicand. That's what we're going to do to convert these. You got to find a perfect square in there because you want to take that out. You know the square root of a perfect square is a nice number. Okay? That's how we do these. But this is a big ugly number. Do you see what perfect square is in 108? Okay. Try 4. Does 4 go in there? 108 divided by 4, because I know 4 is a perfect, oh look, 27 times. Okay? But they're already telling us what to do. 3 must go in there. That's where they're leading us. Okay, so let's see what they want us to do. 108 divided by 3, 36. Is 36 a perfect square? Yeah, okay. All right, well, let's do what they want. 36 times 3. I can split this up into root 36 times root 3. And why did we do that? Because I know what this is. It's a perfect square. I can take the square root of 36. That is 6. So 108, root of 108 becomes 6 times root 3. And that is more simplified than root 108. The numbers are smaller. Okay? How do you know if you did this right? If you're allowed your calculator, you check it. You should never get one of these wrong. Because this, as a decimal, better be the same thing, okay, as 6 times root, not 2, 3. Voila. Do those look like they're like close to the same? Yes. Now I know I did it right. Okay? So you keep going until there's no more perfect squares in this number. If I just took out a 4, are there any more perfect squares in there? Yes, there is. So if it says simplify, that means fully simplify. You got to keep going. That's why they chose 36 times 3, not 4 times 27, because we would have more work to do. Okay? That may sound confusing, but we'll get a couple more examples. Any questions on that? Taylor, you okay? Oh, right. Okay, and that's what this says. Note, if a perfect square is factored out, like we factored this out, if it's not the highest, the largest perfect square, then the process will continue. You got more work to do. So try, if you can, to get the largest one. Convert the following radicals, entire radical, to a mixed radical in simplest form. Okay? So what's the trick? What do we want to look for? We want to find a perfect square in 50. Because I could go, don't write this, that's root 5 times root 10. I'm going to split that up. But does that help me? Do I know the square root of 5? No. Do I know the square root of 10? No. I'm stuck. But what if I did this? Root 25 times root 2. Do I know the square root of 25? Yes. That's 5 times root 2. Now it's a mixed radical, and it's in simplest form. I don't know the square root of 2. There's no more perfect squares in 2. Okay? That's what we're doing, guys. Root 45. What's a perfect square in 45? Who knows their times table well? And the better you know it, the more likely you are to get the right answer quickly, right? 9 times 5 is 45. I can split root 45 up into root 9 times root 5. Okay? Is this thing the same as this thing? Yes, it is. It better be. You can't change it. All we're doing is converting it. Now, why did I do that? Because I know the square root of 9 is 3. This I can't do anything with, so that's fully simplified. Okay? 320. They get a little harder. It's not as easy to find a perfect square in there. But is there a way for us to find all the factors in 320 and maybe figure it out? Did we show you how to do that? Why did we show you how to do that? This is 10 times 32. 10's 5 times 2. 32 is, I don't know, let's go to 16. 16 is 4 times 4. Is that fully prime factorized? No. Lots of people wanted to leave a 4 on their quiz. Okay. 320 is 2 times 2 times 2 times 2 times 2 times 5 times 2. Now, how does that help us? Well, we want to find perfect squares. What's 2 times 2? Let's use a different color. That's 4, right? What's this 2 times 2? That's 4. Right? Do I have another 2 times 2? That's 4. So 320 is also 4 times 4 times 4 times 5. Now, do you want to take a 4 out and make it 2? Sure. But remember, we want to find the highest perfect square we can. It's a lot less work. Okay? So, do you think 320 is also, what's 4 times 4 times 4? Yeah, the cubed root of 64 is 4. We should be getting familiar with some of these cubed root numbers. Do you think 320 is also 64 times 5? Yeah, well, let's check it, because my prime factorization is terrible. I want to make sure I didn't make a mistake. Look at that. Is 64 a perfect square? That's what we want to break it down into, okay? I know the square root of 64 is 8. That's 8 root 5. Okay? That's why we like prime factorization, because it tells us what our factors are that go into there. Now, I'm going to redo this question. I don't know that, okay? Don't copy this down, just have a look. You can still get the right answer. I don't know 320 is 64 times 5. I just want to try 4. How many times does 4 go into that? Oh, 80 times. Okay, let's do that. So this is part 2. I'm going to break this up into root 4 times root 80. Okay, because I know that's a perfect square. I know that's 2. Okay. So it's now a mixed radical, but it's not in simplest form. Are there any more perfect squares than 80? Yes. So I'm going to convert this into, I know that's 4 times 20. Hey, I got another perfect square. All right, so this is now 2, this is 2, and I have root 20, or 4 root 20. Now is it simplest form? There's no more perfect squares than 20? I got another 4, don't I? Okay, see how much work this is? That's root 4 times root 5. This is root 20, isn't it? Okay, got another perfect square. So that's 4 times, this is 2. I still have root 5. 8 root 5. Now am I done? There's no more perfect squares inside 5. Okay, which way would you rather do it? This way or this way? Yeah, okay. Try if you can to find the highest perfect square. Hey, you still get the same answer, right? But this is a lot less work. All right? But if you don't see it, then you're going to do this, guys, because you want the mark, right? Okay? Convert the following radicals to mixed radicals. Hey, it's already a mixed radical. Yes, but it's not in simplest form. There's a perfect square in 192. What is it? I don't know. What's half of 192? 96. Okay. 96. Let's half that. What's half of that? Is that 48? And 48, I'm going to cheat a bit here. That's 16 times 3. Okay? I know most of you don't see that. You'd probably, well, you know what? Let's see. You know it's 4 times 12, right? Okay? Let's leave the 4 there. I don't need to prime factorize this. I want to find perfect squares, the largest one, okay? And that's, here's another perfect square. Is this another perfect square? Yeah, that's 4. What's 4 times 4 times 4? Is 64 times 3 192? Aha. Once again, that's what I want to use. So this, I already have a 2 there. Don't worry about it for now. You just want to carry it down. Root 192 is the same as root 64 times root 3. Okay? Remember, this is the same as this. I didn't change it. I'm just converting it into something that I know the perfect square of. Root 64 is 8. So I have 2 times 8 times root 3, or 16 root 3. Okay? Is this enjoyable? What would you rather be doing? Like French?
I would rather be.
Ew.
French is great.
Okay. All right. Same thing. Don't worry about it. It's just 3/4. Okay? Just like the 2, we're going to multiply 3/4 by... Does anyone see a nice perfect square there? Divide it by 10. Do you see one now? Root 16 times root 10 is root 160. You can split it up, right? And why did we do that? Because I know what the square root of 16 is. It's 4. Are there any more perfect squares in 10? No. 4 doesn't go into it. 9 doesn't go into it. Okay, that's it. All I have to do is reduce 3/4 times 4. Now, how do you guys do that? Do you go 3/4 times 4? Multiplying fractions, just multiply straight across, top and bottom. I don't have a bottom, so let's put a bottom in there. That's 12 over 4 times 1. Okay, 12/4. Is that how I want to leave it? No. How many times does 4 go into 12? 3. Okay, that's one way. You want to see the big kid way? Yes, you do. You liars. Does it matter what order I multiply or divide in? No. Let's rearrange this. Okay, because 3 times 4 is the same as 4 times 3. What's 4 divided by 4? That's 3. Okay, just go here and go 4 divided by 4 is 1. I got 3. Okay, now are you happy you saw the big kid way? Yes, you are. Okay. Uh-oh, fractions. What do? Do you know what the square root of 7/9 is? I don't. But what can I do with this? Think logically. What are we doing here? We're splitting up radicals into things that will help me. Haven't done a division one yet, but we've been splitting things up. Let's just split it up and see what happens. This is the same as root 7 over root 9. Oh, can I do something with root 9? What's the square root of 9? Can I do anything with root 7? No. So then leave it. You're done. That's all you can do. Okay? Don't make it a decimal, because it says we want these as mixed radicals. Is that a mixed radical? Is there a number in front of that root 7? No. Is this the same as this? What's the number in front of that root 7? 1/3. That's the same as this. Okay? Do I have to have the 1 there? No. Okay? Okay, there is a number in front of this root 7. It is 1/3. Okay? Root 7 divided by 3 is the same thing as root 7 times 1/3. All right? Okay, that's all converting and simplifying it. We have to do something else. We have to convert a mixed now to an entire. I'm sorry I have to give this both on the same day, but if we don't do this, we're going to run out of time. Okay? So, this is a mixed radical. I want to make it an entire radical. I don't want this number out in front. I don't want any number out in front. I want this to be an entire radical. So you need to tuck that 3 inside the radical sign. Here's what you ask yourself. 3 is, because we're dealing with square roots, tomorrow's cubed roots, 3 is the square root of what? I want to make this. I want to make it a radical. I want to make it square root of something. So the square root of what is 3? It's 9. Right? Square root of 9 is 3. Is this the same as that? It is. I haven't changed it. This is 3. This is 3. But now it's a radical. And I can Instead of splitting it up now I want to combine them. I want to bring them together. What's 9 times 14? That's 90 and 36. 126. Is there some strange way to check this to know I did that right? You can put this in your calculator and get a decimal. It better be the same decimal as that, or you did something wrong. Okay? I'm not going to do that because I want to give you guys more time to work on this stuff. Okay? Convert these to entire radicals. You know it's an entire radical when there's no number out in front. How do I do that? 2 is the same as the square root of what? Yes, times root 5. And join these together. That's root 4 times 5, or otherwise known as root 20. Okay? 4 is the same as root what? Times root 7. Join them together. That's 70 and 42. Is this an entire radical? Yep, because there's just a 1 in front, if you want to think of it like that. Or you can say there's no number in front, which is technically wrong, but if that's the way you're going to get the mark, then hey, use it. 10. Square root of what is 10, Kelvin? Good man. Is this the same as this? Every step, you ask yourself this. Yes, it is. I didn't change it. I'm just making it an entire radical. I'm just converting it, okay? It's got to make the same decimal. Let's not worry about that. I'll never give you something like that on the test. Let's do this nice one. Okay? The square root of what is 3? The square root of what is 2? Is this thing the same as that? It is. Okay? I didn't change 1.5 or 3 over 2. I just made it radicals. Times root 8. Okay? I can combine these in the same radical. Times root 8. Okay? And I can also combine these in the same radical. 9 times 4 times 8. Could you have done the top part first and then the bottom part? Sure, doesn't matter. You could have done it that way. So these are all in the same. Now, do you want to go 9 times 8 divided by 4? Or do you want to use the big kid method? How many times does 4 go into 8? 9 times 2 is 18. Because some of us don't know 72 divided by 4 is 18. You have to pull out your calculator, right? That's why this is a better way to do it. Would I check to see if that's the same as this as a decimal? Yep, but you got to know how to put that in your calculator, right? Negative. Don't worry about it. I can't take the square root of a negative number, but I can say that is the same as that. Is this the same as that? Do you believe it? Right? Do the radical first. Root 25, that's 5. This is minus 5. This is minus 5. This is the same as that. Don't think you have to have that minus sign in the radical sign, because you can't do that. There is no number multiplied by itself to give us minus 25. Okay, times root 7. So minus, what's 7 quarters? That's 25 cents short of $2, right? Okay. I'm going to skip this one for time's sake. I like giving you guys at least half an hour to work on this stuff. But some of us need a little refresher for this Greek guy who lived 400 years ago, who ate lots of souvlaki and pita. Okay, he was Greek. Pythagoras. Pythagorean theorem to determine the exact value of, what are they asking for? This length right here. AB. Is this looking pretty nasty? Or does it look like fun? Okay, express this answer as an exact value. Okay, in grade 8, we did decimals because you didn't know how to convert radicals. You would love plugging it in your calculator and getting a decimal. And the question would have said to the tenths or the hundredths. Okay, we want this as an exact value. That means we want it to be left as a radical. How do I find AB? If I just look at this triangle ABD, okay, I need to know these two sides in order to figure out this. What's Pythagoras again? C squared is A squared plus B squared. Okay, C is always the side opposite the right angle. It's always the longest side. It doesn't matter which one's A and B. Okay, this could be AB, BA. The legs of the triangle don't matter. That's what we call this. Okay, I know little a is 6, but I don't know this one. But that's why we give us this other triangle, so I can figure out that one, and then use this one to figure out the length of AB. So we have to do Pythagoras twice here. All right? Welcome to grade 10. So let's look at this triangle first. Okay? A, D, C. This is 12. This is 8. I want to find, let's call this X. I want to find X. Again, I use Pythagoras to do it, but this time I'm given the hypotenuse, right? I want to solve this for X. So I'm going to rearrange this formula. I'm going to subtract B squared from both sides. Okay? So C squared minus B squared is A squared. I'm solving this for A squared. A is X. Okay? So X squared is C squared, 12 squared, minus B squared, 8 squared. So X is the square root of, what's 12 squared? 144. Minus, what's 8 squared? 64. So what's 144 take away 64? Let's not hurt ourselves. Whoop. Someone's got it. What is it? Yep. But let's prove it. 80. Okay? That's what X is. Root 80. That's a length. You can find the decimal of it, but we don't want the decimal of it. You leave it like that. Okay? I don't want an approximation. I want the exact value of X. That's root 80. You'll see it actually makes your life a little nicer. Okay? That's step 1. What am I trying to do? I'm trying to find AB. So X, that's this length. That's here. That is root 80. This is 6. And AB, that's C squared. AB squared is little a squared, 6 squared, plus root 80 squared. Okay, that's going to help me solve the distance of AB. So how do I get AB just by itself? By taking the square root of all this stuff, okay? Remember, whatever you do to one side, you do to the other side. You just did the motions in grade 8. You didn't really understand it, okay? And when I take the square root of AB squared, it just becomes AB, right? When you take the square root of C squared, it just becomes C. What's 6 squared? 36. What is root 80 squared? 80. The square root of C squared is just C. The square root of 80 squared is 80, okay? You can think of it like the square root sign cancels out the square. So, AB is, what's 80 plus 36? AB is the square root of 116. That's exact. Okay? Is that now simplest mixed radical form? Or can I find a perfect square in 116? Well, let's have a look. Prime factorize it. Take out a 2, and what do I get? Mr. Galloway. Very good. Nice. Okay. Take out another 2. Let's half that.
14.5.
I don't want to take a 2 out of 29. Is 29 a prime number? All right, we're done. 116 is 29 times 4. I want to split that up into 29 times 4 because I know the square root of 4 is 2. But I don't want to write it like that. I want to have the 2 in front. So the answer to this is 2 root 29. Okay? Exact. Part B says make it a decimal. I hope you can now stick that in your calculator and get a decimal from that. But this is the important part, right? We want exact value. We don't want a decimal. Okay, numbers. 1, 2, 4 to 6, 8 to 10, and 12 and 13 again are the most important ones because those are like multiple choice questions that are like going to be on the ones on the government exam.